like Ali is here. Yeah, the Ali is here, a lot of brands here. So thank you for attending this seminar. And I'm going to first a little bit about myself. I got my degree from Pennsylvania State, and did my postdoc in USD, and then work as North Dakota State, and then come to China Agricultural University. It's a long time not seen out. What I have done, what my team has done. So I'm so glad to share with this very recent work of my lab with you guys. The presentation title is AI Powered Apple Production. I have been working with Apple since my PhD, working on Apple Harvest platform, and then work on Apple in field sorting, and now mainly working on Apple Harvest robotics, and also in field sorting. So I'm going to present in three major topics, like research background and key technologies of AI in Apple production and the trends for AI to benefit Apple production. So the first part is research background. So Apple ranks top 5 foods in the world. I don't know, maybe China or the world is developing so fast. When I was a kid, apples, pears, peaches are the most popular fruit in my life. But nowadays, with the technology progress, and also the more communication, closed communication between the world, there are a lot of variety of fruits in China or even the world, such as blueberry, cherry, and even durian. So a lot of fruits make people feel apple is not that important fruit, but actually it is still the top 5 fruits in the world consumed. And apples can be consumed in fresh mode. I mean, you can eat apples, and also apples can also be uh uh processed in a lot of manners, such as apple jam, apple juice, some other ways. And also apple is popular also because it has a very long shelf life. I mean, in China, in the whole city, or in the world, everywhere, in the 4 cities, you can see the apples on the shelf. And also, apples is famous because has a lot of various nutrient elements. It's good for the health. And a lot of people have been published to relate the consumption of apple with the health conditions. And also, there's a proverb in the world that one apple a day keeps doctor away. So it has been demonstrated that apples are benefiting our health. The Apple industry provides millions of job opportunities in the world, not only in China but the world. The whole Apple industry provide a lot of jobs for the workers. And here you can see the world apple production area. You can see apple can mainly produce in the north part of the world. And I mean China produce a lot. China and also America produce a lot of apples. And more what I want to press here is that you can see most of the world, apples can be planted and grown, which means that almost everywhere in the world you can see apples. That demonstrates that it's top 5 fruits in the world. And also you can see here are so many countries like Italy, Poland, United States of America, China, France, Turkey, Japan. Here Vietnam, India, Indonesia, Philadelphia, and you can see so many countries are heavily involved with the apple industry, exporting and importing. So here's the key apple exporting countries, and these are the key apple importing countries. So all the countries are heavily involved with apple trade input and output. So we can conclude that Apple industry plays an important role in the economy of many countries. Here, we just had a quick glance of what's happening for the Apple industry in the world, and here we are going to be more focused on the Apple industry in China. You can see China ranks top one in Apple growing area. You can see almost half of the Apple yield the planting area. You can see China is global. China is almost continuously like about 50% of the Apple industry in the world. And here you can see apples can produce in a major area of China, mainly in the north part. In the south part, like Hainan, like Guangxi or Guangdong is for the because the season is hot, so it's difficult to produce apples. But the whole part in the north part of China produce a lot of apples. The top province in produce apples like in Shanxi, Shandong, like Xinjiang, you can see they are north part of China. So China is an important uh, Apple Apple industry player in the world. I mean, China plays an important role in the world Apple industry. And China Apple industry when I see that China Apple industry faces a lot of challenges, and I have gone so many Apple analysts in the world, and growers always complain that they have less benefits. So we have to find out what's the problem that limiting what's the problem that the Apple industry is facing. Like then we have to find out the problem and then find a way to address the problems. So Apple industry is labor intensive. You can see the Apple production whole circle are mainly labor involved, such as harvest, in-field sorting, like pollination, thinning, bagging. So all these activities are mainly operated by workers. So there are no suitable like machines that can replace human for this work. So the Apple production is very labor intensive. And based on our discussion with the Apple growers and also based on our literature search online, we found out that 40 to 60% of the cost is on labor. So this is a big problem for the sustainability of Apple industry. And all strength is required. Why strength is required is that you can see here the people are like doing Apple harvest. This guy has to wear the bucket. You can see that this bucket, when the bucket is full, it's about 20 kg. So this makes the work is very strength required, especially the harvesting. So for those like older people or very young people or female, it's difficult for them to handle this work. Only or carrying a bag with 20 kg always on your shoulder is a big problem for the workers. And also facing, so shrinking labor pool is also a problem. You can, not in China, but the world, there are less agricultural workers, but more and more workers like in the like city, the urbanization, and also the increased labor cost in one was in the US. So the Apple harvest cost goes from like 15 hours per $15 per hour to more than $20 per hour because of the pandemic. And a lot of workers cannot come to the US to complete the Apple picking work. And also in China, in the west part of China, I mean Xinjiang produces a lot of apples. And here you may spend like more than $60. I mean $60 a day to hire a person to do the apple harvest. And also the aging issue. The China is going to be a aging country, more and more older people, and this makes the because the work is like strength required, so we don't have like enough a strong person. I mean the aging put a lot of strain on the Apple industry. So China Apple industry faces a number of challenges related to labor. But this is the problem is increasingly more and more serious, and we need to find a solution to replace the people work with autonomous systems. And you can see here's also this person is working on apple harvest, and also this guy, excuse me, this guy is using the semi-automatic scissors to cut the branch. I mean, do the pruning. And this another guy, this person is working on field sorting. So all this work are very like labor intensive. So China, not only in China, but the world, China and the world, Apple industry faces a number of challenges related to labor. Oh, nowadays the progress with artificial intelligence going fast and fast, and people are trying to using AI to replace our workers, and a lot of things has been done by AI, like large scale models can answer whatever question you have, and ChatGPT, and some like your plate detection and recognition. So many things have been automated, but the Apple Harvest is still far away. The first is the AI technology iterates at a rapid pace. Significant breakthroughs have been made in areas such as deep learning and machine learning, driving scientific and technology progress. And you can see all these samples. So the AI makes the computer makes the system to be able to think like human being, so they can always make right decision to do something to replace humans. So this can replace the human work. And also there's a wide range of industry applications. AI penetrates into healthcare, finance, manufacturing, agriculture, and so on to improve productivity and promote industry upgrading. So nowadays for the AI in healthcare, like a lot of the wearable devices, they can monitor your pulse and determine if something is going to happen to your health. Also, the AI is trying to be able to use in agriculture. So this is what we are trying to discuss today. So AI is used in agriculture for decision making and replace labor. So a lot of things have been done for AI for like disease monitoring and some other stuff. Improves everyday life. Intelligent assistants, self-driving, and other AI products are coming into millions of homes to improve people's quality of life. Agricultural intelligence equipment reduce labor costs and improve labor income. So the most popular topic or the hot topic is self-driving cars. In China, there are some cars are coming to the commercial application, so they don't need any involvement of drivers. And also comes to the millions of homes like smart furniture and some other things that has been applied to our everyday life. And you can see here are some samples of using AI robotics to replace human work. Like this one is trying to pick, cut the grape and apple harvest, and this one doing phenotyping or the cotton picking. So artificial intelligence leads to the development of agricultural intelligence. I mean, because the AI technology can be used in almost everywhere in the life. So agriculture is also a scenario that can be used to be AI'd. And also the second part, I'm going to discuss some detailed technology progress of AI in Apple production. Because of the time limitation, today I'm going to mainly focusing on two topics. The first one is the Apple harvest. The second one is the Apple in field sorting. And also, in the future, if you have interest for using like the AI for pollination, for like thinning, pollination, and bagging, my team is also working on those topics. But today, I'm going to only to discuss two topics: apple harvest and apple in field sorting. So this one, the AI-powered apple detection. So when we want to develop, when we want to realize apple harvest, we first need to know if it's an apple and what's the coordinates of the apple. So object detection, object detection means we need to know this apple. Object detection methods, including fruit identification, have traditionally relied on visual images. Here you can see we are trying to use the multi-source data for apple detection. You can see here we use the color image and the AR image, and we are trying also to use the point cloud to have all this information fused to realize apple detection. And here you can see a lot of cameras or a lot of sources that have been used for apple detection. Here's the monochrome a camera. This has been like the very early stage study. People use this one because at the early decade years ago, there's no color camera, so people had no other choice but to use the black and white camera to detect the apples. So this monochrome camera and also the full color camera, I mean the RGB camera, and people still are going to use the thermal and the stereo. The mono camera can extract the texture and geometric information, but its limitation is that it does not exist of color details. And color is very important because for most apples, they are like red when they are ripe, and the branch and the leaves are mainly in like gray or green color. But there are some like exceptions, like the Grand Smith, the color is like always green. For the color, the brown and corn are like it can extract the color texture and geometric information. The limitation is that it's easily affected by variation in lighting. The variations in lighting is always a big problem, like in the morning, or in the noon and in the afternoon, the color is very different. So to avoid the effect of the lighting, natural lighting, sometimes the people are using like what? They work at night or they work in the day, but they build an image chamber to provide artificial illumination, so they can control the artificial illumination. So this will make the model more robust. And here's the thermal signal and heat radiation. So the thing is that when in the daytime, in the afternoon, sometimes the apples are more hot than the leaves and branches. But the limitation is that it relies on subtle temperature variations, and most of the time in the day, apples are like apples are in like at night. Sometimes the apples are like the same temperature with the leaves and the branch. And also the stereo imaging, so they use depth and point cloud to find apple shape. The limitation is that it needs long response time and partially affected by ambient lighting. So different types of cameras are used to capture images for extracting various features. This is the summary of what we had done. This is also a paper our team has submitted to a journal working on summarizing the techniques used for apple detection. Here are machine learning apple detection methods, and this is how the whole procedure of how the machine learning works for apple detection is had a feature extraction, and then you find a region proposal and object classification and non-maximum suppression, and then object localization. Here you can see the model how to process for the machine learning. We usually to doing the feature engineering. I mean, we manually extract the features from the image, and then we fit the features into the classifier, and then we train the classifier, and then by what we have trained, the classifier is able to detect the apples. And here the method here, it's not very detailed, but general. You can see the KAN is not as good as AN, then the SVM is always has a good performance, and then has the advanced, we can combine all this technology to have a good performance of the apple detection. And the feature extraction method capture valuable data for distinguished objects. Apple-powered apple detection, deep learning method for apple detection. So the deep learning offers novel and advanced solutions leading to the extensive use in future recognition. As I just mentioned, for the machine learning, people like have to extract the features by their domain knowledge, like which kind of texture based on the experience and good performance they will use it. This is good and this is also bad. This good is that because this is mainly related on our domain knowledge, but the bad is that every expert has different domain knowledge. So And also it's very like the performance is very uncertain sometimes because the image is also affected by the lighting, and also because our human can only have we are living in a physical world, we can only know the knowledge, we only have the knowledge, or we have, but we don't know of some other subtle features that can represent the Apple detection localization for apples, but we don't know that. So we don't know. We don't know that means we don't know the proper features for this things. So this is also a negative thing. But the deep learning has successfully addressed the problems. It can produce like high level, middle level, and low level like the features, and then they can combine all these features and also select the proper features that have good performance for apple detection. And you can see we can combine these features with more features included. We can have we can have like a good a good performance in apple detection. So deep learning offers novel and advanced solutions, leading to their extensive use in photo recognition. This like deep learning has been used in apples, and also they have been used in a lot of like apple detection, not only in apples but other fruit detection to address these problems. And deep learning-based networks used for apple detection tasks. Apple detection models based on seeing networks fall into three categories. So two-stage, one-stage, and hybrid methods. For the two-stage, one-stage, and hybrid method, for the two-stage methods, it includes like RCN, SPP-NET, fast RCN, faster RCN, and mask RCN. While for the one-stage models, it's the most common one, like YOLO-V, like Sierras and SD RetenNet. And also the hybrid method, they combine the one to two methods and have the hybrid method. For the two-stage method, they first detect this area and finally the region of interest is an apple. While for the one stage, it does not consider by industry of this an apple. So you can see like this two-stage model, we have like sample like 100 papers. We found out that the two-stage and the one stage is more like popular than the two-stage. It's a little more popular because there's a 2% difference. But for the hybrid detectors, is maybe the future is will be hot. But nowadays it's very like very less study in this area. The one-stage model have gained increased usage due to their faster and more efficient performance. So AI-powered apple localization, we need to know that's apple, it's an apple, we know that's an apple, for sure it's the first step. But because we need to do the apple harvest, we need to know, so we need to know like the apple localization, we need to know the X, Y, and Z of the apple to our camera or to more specifically to our end effector. Here we can see, so the first thing comes to mind is that the coordinates of the sensors, whatever sensor it is, like this is a lidar sensor, RGB sensor, or like thermal sensor. So every data is based on the original coordinate of the sensors. While the end effector is always off the sensors. So the coordinates are different because the end effector is part that is going to realize the apple localization. So the first step is that we need to like transfer the coordinates of the image to the region of the end effector. So this is the first thing we need to know. We call it like coordinate transformation. In the very early stage, researchers in France, they are trying to avoid this issue. That then they just mount the camera in the middle of the end effector, so it's the relative position always fixed. So they can use this one. So by detecting apples, they only need to adjust the end effector to make the apples always in the middle of the center of the and the effector, then they can address the problem. But nowadays, we always work on the coordinate transformation to coordinate the different coordinates, the different origins. And here's the 2D, 3D dimension position. You can see the original image, and they can use the 3D point to draw the apple. And also here's the curvature. They may use this curvature. They may use this curvature to estimate the whole area, and we can use the Hopf transfer here to find the apple. Okay, find the real apple. So you can see this not that accurate. And both call centroid, and we always use the also centroid coupled with the distance information to detect as well as localize the apple localization. And here's another thing. So another thing comes to us is that when we do the apple detection, we found that there's a obviously there's always a problem with the concern of the stem. I mean the stem of the apples. As the stem is like detached, the apple has a low price because it's difficult for storage and easy to cause like rot. Well, we want to maintain the stem of the apples in their like apple. So we need to study. So what kind of method we are going to use to detect apples successfully while maintaining the stem with the apples. So we need to always find the orientation of the apples. So when we know the orientation of apples, we can accurately make the decision how to detect the apples. So summary is the axis of the fruit and a vertical rotation from the fruit center to the branch. We need to know this orientation. Only when we know the orientation, we can have a good sucking. We can make a good decision on the suction point, and also we can make a strategy of how to detect apples. And direction from the fruit center to the surface center, and most are assumption, a large error, and from real time. You can see the fruit center to surface center. You can see the fruit center is a little different from the surface center, and also this makes sense for us to understand the apple orientation. And here's a case. A lot of, as I mentioned at the beginning, that a lot of apple robotics have been developed, including our team. And in our team, I have 12 faculty working on this apple health robotics. So I'm going to give you some case studies. Here's a case study of a 7DOF picking system. So multiple joint tandem robot arm and 3-finger gripping the end effector. This is the one. This is done by Davidson. The Davidson got his degree from Washington State, and then he did his postdoc in MIT, Massachusetts Institute of Technology, and then he went to Oregon as a faculty now. This is his like PhD thesis. So this you can see rate is like around 85%, and the cycle time means like how long it needs to detect apples is about like 6 seconds. They can realize the apple detection. So there are a lot of problems with this one, like the positioning error is not very accurate to find apples, and also the seed from the tree branches will also significantly affect the performance algorithm in apple localization and localization and detection. So fruit detection is significantly affected by recognition or localization and shading. The shading will affect the apple detection. And this is what they have done. This research has been done like in 2014 or 2015, I think. So time-wise, it's about 10 years ago. And this is the Davidson work. And here's what we have done with our Apple Health robotics. First, we found out that because it has multiple fingers, the finger is always wrap the apples. This give a problem for the neighboring apples because all apples are always in cluster. So if you attach one apple, it will affect the other apple. So this is a problem. And another problem is that we found out because for you can see this like DOF 1, 2, 3, 4 for so many. So everyone is not 100% accuracy. So every joint has a 95% accuracy. So 95 by 95 by 95, if we go 4 or 5 times, the accumulated error to the end effector is largest. So it cannot successfully or accurately wrap the apples. So to avoid this problem, we made a very short DOF and the effector to realize the detachment. You can see we make this uh, simple thing for the apple and the effector. So it X, Y, and Z is very accurate. And for this one, we have like a suction cup to suck apples and then detach apples. We do rotation and pulling to realize the apple detachment. Now what we have done. Here's a demo of last year. Let's see. You can see the time attach the apples and then by pulling and twisting it can. We always do the first we do approaching the apples and then we suck the apple surface and then we do rotate and pulling to realize the apple detection. We can see it again. It goes to catch the approaching apple and then realize the detachment. Another one. So you can see find the apples in center and then go to detach the apples. So the vacuum suction has a high tolerance of position error because we don't need to for the three fingers we have to be wide open and then wrap the apples. Well, for this one we just need to attach the apple surface and 1 or 2 centimeters offset is not a problem at all. So this is what we have done, and we have done the test of the whole system last year. And because one end effect is too inefficient, so we are trying to make a full robotic arm. So vacuum suction. So as I told just now that I'm going to discuss two topics today. The first one, the apple harvest. The second one is the apple in field sorting. So why we do you can see there are a lot of like apple sorting machine for packing house. So the thing that we are working on in field sorting, what we do in field sorting is that because when you harvest so many apples and put them into a bin, and if there 1 or 2 apples has been contaminated during the storage, it will rot and then spread all the disease to the whole bin of apples, cause big economic loss. So here we are going to trying to develop the apple infused trying to apple infused sorting system. Yeah, what I worked in the USD, and this done by a postdoc maybe 10 years ago. This is the first prototype for apple infused sorting machine, and this is done by Japan guys or Turkey guys on the individual apples. And here's has been done by my mother university, Northwest Agricultural University. They also work on apple infused sorting. Here's another prototype. And how I power this one? So we have to use deep learning to find the apple the apple evaluation like quality. And we use machine learning and image process and advanced machine learning algorithm to classify the apples. So existing apple infused sorting system cannot meet the practical requirement. I mean, for the for put an example, like this is the backhand roller, this is called a backhand roller, two rollers rotate, so they put apple rotate on the opposite direction. And this one can work well in the greenhouse, but when it works in the field, when there's a little bit of tilt, this will cause apple to fall off from the backhand roller, so this won't work in the field. And also, like for this one, is the cups. This cups it means a very clean working environment. But while you are working in the field, a lot of dust that may cause problem for the whole system. And here's what we have done when I was a postdoc in the US, and also my team and my students, master students and the PhD students are working in this system. And you can see, so this is the speed we can when apples going through, we can detect the apples. We can not only detect the apples, but we can also track the apples. Why we track the apples? Because we need to count the number from 1 to 3, how many apples had gone through. The second thing is that when you track the apples, then we know this apple, and we can continuously collect the images, and then by using 10 or 20 images, we can make the decision. So why we use more than one image to evaluate the apples? Because some bruise cannot see in this image, but it might be seen from another image. So deep learning based detecting apples and adaptive segmentation based on SVM. And you can see AI-powered apple in field sorting has been commercially applied in the US. This is what I have done in the US. But after I come back to China, I tried to do some similar thing, but I found out the apple industry in the US and in China are very different. Because one example is that in the US, most apples have a very long stem. So when you can find a stem in the images, then you can find the equator, and you can easily like evaluate or make a decision or to know what's the damage of the apples. While in China, most apples, because the skin in China, the peel is very thick, very thin, not as thin as US. So the stem may ruin the apples. So in China, all the apples, the stem has been cut. So if you cannot find the stem in the images, it cause a problem for the apple detection, especially for the apple size evaluation. Oh, time is almost there. And I'm going to come to my last section of the first webinar. So trends for AI to benefit Apple production. So challenges and possible solutions. So need to accurately identify the state.
Seems the signal is interrupted. Let us wait a few minutes. Hello, Professor Zhang, can you hear me? Yeah, we lost you. Yeah, minutes ago, yeah.
Yeah, sorry for that.
Don't worry, yeah.
Yeah, sorry for that. I'm coming to the last one. Sorry for that. So the trends for AI to Apple product, the last stage, last one. So the first thing that we need to really identify the state of the fruit. We need to know the state. How do we need to know the most apple in clustering? After you the one apple, it may affect apple. So we want to know the clustering conditions so we can know how to first and balanced accuracy, speed, apple. So we cannot like spend like 1 minute to have the apples. We need to make the decision very quick. So that's apple as localization, and we use them to help. So we need to balance the because we cannot take like high or use our very high. We have limited computation costs in the world, so we have consider the balance between speed and auto size. Similar plant structure less fruit clustering, more robust structure like architecture. So the guys in American US has spent more than 20 years just to shape the tree to be more like used to be more adaptive to the apple harvest. So this has been done a lot study, and nowadays we have like a spindle or like weir the structure to benefit the apple harvest. And still more studies need to be conducted to find like a chip that does not reduce the yield, but it also makes the chip to be more suitable for the harvest of apples. And advanced in edge computing device, artificial intelligence technology, and sensors. So edge computing device, so that's what I mentioned. We need to consider the balance because edge computing device like has very limited computing skills. So we have to consider the accuracy and the real-time effect of the model. And also small object detection method with good performance, accuracy, efficiency. Because for the generally speaking, the apple detection is like a small object detection method, and we need to find them on a good accuracy and efficiency. And this is a technology requires the precision, model size, and real time. Is we need to find a balance. So that's smart rate. That's part of smart rate. Yeah.
Yeah, thanks.
Sorry for the.
Yes. Yeah. Thanks very much for your excellent presentation. Yeah. Anyone, if some question, yeah, you can directly ask Professor Zhang or just leave a message in the chat board. Yeah.
Yeah. Anyone have a question, please?